Hello everyone, this is Sam Lwash from Class 3 SEITech Solutions. In this video I'll be briefly discussing the first RTOS project, which is basically a simple time-based OS scheduler. It will schedule 3 tasks. Each one will toggle a certain LED with a certain periodicity. Red LED 1 every 1 second, yellow LED every 2, and red LED 2 every 5 seconds. You can also find the important files or the files that have been changed through the implementation in this tree to quickly move between each file. Mainly you can divide these into 3 changes: the main.h, main.c files, and an SOS interface private in program, which holds the implementation for the scheduler itself. And finally, the SOS tasks interface private and program, which holds the tasks functions, which are basically toggling the LEDs. And a final change to this stm32f1xx_interrupts file to just update the SEITech handler to notify the SOS that a tick event has occurred. Okay. For the SOS itself, you can find the TCP or the task block type def as a struct. Each task will have its own periodicity, priority, and pointer to its function. And you can also find the SOS status codes. Okay, no tasks created. If you're trying to start the scheduler with no tasks created. Invalid arguments, and tasks full if you are trying to create a new task and the queue is already full. And for the prototypes, SOS create a task, SOS start the scheduler, and SOS tick event, which is called by the SEITech handler. For the private file, you can adjust the max task count, which changes the queue size for the scheduler. Okay, these are the states for the scheduler itself, whether it's stopped, which is the initial value, idle, waiting for a tick event, running is checking which task should run right now. And finally, struct to hold all the tasks in an array, and a counter for the initialized tasks. And these are just helping macros. For the SOS tasks itself, you will find 3 prototypes for each LED task, and in the private you can adjust the GPI opens for each LED of the 3 LEDs we have. Standard attach and the implementation itself. Little quick note for the create task: it will dynamically update the tasks array with respect to the task priority, meaning if we, like I did in here, if we created a first task with priority 0, which is the highest, it will be at the beginning of the array, and then we added another task with priority 2, it will follow the previous one. And then if we added one with priority 1, the SOS create task API will automatically insert this task in between these 2, so that the tasks array are always sorted with the highest priority first and the lowest to follow. You can add some debug points on these 3 lines to validate what I just said. Can do this quickly by erasing the chip memory. Going to the IDE, I have 2 breakpoints on these 2 lines. Okay. Okay, creating the second task, I will just step over. Now we are creating the final task with priority 1, and we should have these two tasks at the beginning of the array. So I'll step into this line, going to the tasks global variable. You'll find the tasks count is 2. First task priority is 0, which is red, one lit blink. Okay, and second task priority is 2, which is red 2. I'll be adding the third task now. Let me stop at the return in here. If you go back and check this, you'll find the count is 3, and the red one as is, and the second task is updated with the yellow LED, which has a priority of 1, and the second previously task that was in here is now in the third index with priority 2, which is the red 2 task. Anyway, you can now see the let me stop the debugging, click on reset. You can now see the first LED toggles with a rate of 1 second, the second LED toggles every 2 seconds, and the third LED toggles every 3 seconds, which follows the tasks in here. Hope you enjoyed this video, and thank you for watching.